Hi everyone. In the previous classes, we have seen how to construct synchronous up counters, right? So, and also we have discussed how to construct synchronous down counters, right? So the point here is, why can't we construct a circuit where the circuit will act as up counter or down counter based on the inputs, right? So that is what I would like to discuss in this particular class. So for that I have taken an example for 2-bit synchronous up down counter, right? So basically you know the procedure how to construct a synchronous counters. The first one is you have to identify what kind of flip-flops they are. So here I decided to go with the construction with the help of T flip-flops, right? If I am going to find the design for T flip-flops, the second step is you have to write down the excitation table for the T flip-flops, right? So I am going somewhat fast. If you want, you can go to the earlier videos, right? So the second step is you have to go with the excitation table for the T flip-flop. So if I am going to have present state as Q1 and next state as Q1 plus 1, what might be the T flip-flop value, right? So the possibilities are 0 0, 0 1, 1 0 and 1 1, right? So states are changed at which locations, not changed at which locations. 0 0 is not changed, so latch mode. So this will be 1 1 guy, right? 1 1 is not changed, so it is latch mode, so 0, and these two are toggle mode, so I have call it as 1, right? This is the corresponding excitation table for the T flip-flop, right? So this will becomes under step 2. Once we're done with the step 2, you can go with the step 3. In step 3 you have to go with the state diagram as per our requirement, right? The requirement here is, in the single circuit diagram they are asking for up as well as down count, right? Let us go with, if we are going to have 2 bits, how many possible values are going to get? One is 0 0, another one is 0 1, another one is 1 0, another one is 1 1, right? So this is what we can call it as up counter, right? So 0 0 it is moving from 0 1, 0 1 it is moving to 1 0, 1 0 it is moving to 1 1, 1 1 it is moving to 0 0. So this is what we can call it as up counter, right? So when you go with the down counter, what is going to happen? If we are at 1 1, it will move to 1 0. If we are at 1 0, it will move to 0 1. If we are at 0 1, it will move to 0 0. If we are at 0 0, it will move to 1 1, right? So red color indicates down counter and my blue color indicates up counter, guys, right? So this is the respect to state diagram, right? Once we draw the state diagram, we can go with the respect to excitation table, right? So if you are trying to have the excitation table, basically you are going to have the present state and next state. This is as per normal procedure, right? If you are going to take, let me take somewhat above, this will be Q2 and this will be Q1, and this will be the Q2 next state and Q1 next state, right? So this is present state and this will be the next state, guys. Here I what I will do now, I will try to take out first up counter values, right? So if I am going to have 0 0 as possibility, 0 1 possibility, 1 0 possibility, 1 1 possible, right? If 0 0 is the value, is the present state, what will be the next state? 0 1. If 0 1 is the present state, what will be the next state? 1 0. If 1 0 is the present state, what will be the next state? 1 1. If 1 1 is the present state, what will be the next state? 0 0, right? So these are the possibilities for up counter, right? Meaning that if I say, I can call them in single blue color for your understandability, right? If I try to write down the down counter values, right? So down counter values possibilities are what? 0 0, 0 1, 1 0, 1 1, right? If I am presented the present state as 0 0, what will be the next state? 1 1. If I am presented as 0 1, 0 1, what might be the next state? See, if I am presented the 0 0 as a present state, what might be the next state in down counters? Red color, right? So that is 1 1. That is what I have written. If I am presented as 0 1, what might be the next state in red color? 0 0. 0 0. If I am present at, wait, if I am present at 1 0, 1 0, what will be the next state? 0 1. If I am present at 1 1, what will be the next state? 1 0, right? Yes. So if I extend this table, So this is what is for the purpose of down counters, right? Yes, but the point is here we need to have a kind of excitation table where it is used for to represent both up counter as well as down counter, right? Can we able to take some kind of control in asynchronous up and down counters? Also we have taken some kind of control, right? For example, if I take the control input as m, control input as m, the meaning of m is it's a kind of a control input. If I say that m value is 0, what is the meaning of this one? User is asking for to perform up counter. If I say that m value is 1, user is asking for the performance of down counter. Down counter, right? Next, try to construct the excitation table for this. If you go with the excitation table, as it is 2-bit counter, you require to have two flip-flops. One is T2, another one is T1. So T2 you are going to get the values as, see, this is 0 0 latch mode, so this will be 0 0 1 changing toggle mode, 1 1 latch mode, 1 0 toggle mode. What about the T1? T1 is 0 1 toggle mode, 1 0 toggle mode, 0 1 toggle mode, 1 0 toggle mode. Similarly, in the down counter also, try to take this is 0, this will be the 1 toggle mode, 0 0 latch mode, 1 0 toggle mode, 1 1 latch mode, right? Similarly, if you take out the T1, 0 1 toggle, 1 0 toggle, 0 1 toggle, 1 0 toggle, so all are going to be ones. See guys, I haven't done any magic here, I just have gone through the combining of both the up counter as well as down counter. Now once we drawn the state diagram and circuit diagram, circuit excitation table, you can go with the simplification, right? So how can we simplify it? So you can able to take the value of T2, right? What might be the value of T2? T2 value is this one. You can able to get this value by combining this three, M, Q2 and Q1, right? So for example, if I try to take, so how many values are there? 8 values are there, M, Q2 and Q1, right? Similarly for T1, guys, I think T1 you need to go with the table, right? Because you can directly understood Q2 Q1, so all are going to be 1, so it will be, so the T1 value is going to be 1, is going to be 1, right? What might be the T2 value? T2 value is, so you have to go with this particular value 001 and 011 and 100 110. For this you have to place the 1, right? So 001, so if I extend with the values 00 01 11 10, this is 01, right? So 001 is going to be 1, 011 is going to be 1, 1001 110 is going to be 1, right? Yes. How can we combine? If I combine these two as one unit and these two as one unit, this is the best possibility, right? So now what might be this value? This value will be definitely M, because it is 1, and what is not changing? 0 is not changing, so M Q1 bar. So this value will be M bar Q1, right? Yes. So which is equal to, so T2 means what? M Q1 bar plus M bar Q1, right? Yes. Now once we got the equations, once we got the expressions, can we able to write the logic diagram for this? Yes. So what we can do, simply take the two T flip-flops and you are going to connect it with the same clock, and this will be the T1 and output is Q1 bar, T2 Q2 and Q2 bar, right? So as per the expressions, T1 value you have to pass as 1, value I have passed as 1, right? Yes. What might be the T2 value? T2 value, you have to have this combination circuit. This combination, right? It is an expression. This should be combination circuit. So if I say that m I have taken, this is a kind of a line which will produce the value of m. You have to take m and q1 bar, m and q1 bar, right? So this will be the m q1 bar, and the next expression is m bar q1, right? So what you can do, this can be a kind of NOT gate. You will get m bar, then you can go with q1, m q1, finally you got. Then you have to use a kind of OR gate that should be connected to the T2, to this, right? So this is the corresponding diagram which will get 2-bit synchronous up down count. Synchronous up down counter. I hope understood clearly. Thank you.